Hi everyone, welcome to the first video of the ICT Theory series. In today's video, I'll cover the first chapter of the ICT Theory, which is types and components of computer systems. Alright, so first let's look at the syllabus. So we are supposed to know and understand hardware, software, analog data, CPU, internal memory, input and output devices, backing storage, the different kinds of operating systems, desktop computers, mobile computers, and then finally the extended realities, virtual realities and stuff. Alright, so we will begin with the top, from the top. Alright, alright. So first we have hardware. Now what is hardware? Hardware basically refers to physical components of a computer, right? And they can include your motherboard, which is the main circuit board of the computer, the processor, or the CPU. The CPU basically processes information from the input and output devices and executes commands. Now, one thing you can note here is that whatever I am saying and whatever is written here has been directly extracted from the mark schemes of past papers, so you can use these as your examples or definitions while you're practicing papers, or you can use these to make notes. Alright, now we have the internal hardware components, which include the RAM, we have the and then we have the other hardware components, right? As I was saying, the RAM, the SSD, the HDD, which is for the secondary storage, and we have the sounds card and the graphics card. The sound card is responsible for all the audio output and input from our device, and the graphic card is responsible for the display. Alright, and then now let's practice a quick question. Circle two items which are internal hardware. We have actuator, keyboard, linker, sound card and processor. So take a moment and answer the question. You can go ahead and pause the video and answer it. Alright, now the answer is sound card and processor, as we looked earlier. Alright, this is a question from an actual past paper. Alright, so you should be expecting such questions as well for 2 marks. Right. Now moving on to software. Software basically controls the operation of a computer, right? And then we have two types of software. We have the system software and the application software. Now what the system software does is basically that it provides services the computer requires to operate. Alright, so for example, the compilers, the linkers, the operating system, the utilities, right? Those are examples of the system software. Without that, the computer cannot run. Alright, imagine your computer without an operating system. How will it be able to run? Alright, then we have the application software. The application software basically provides the services the user needs to complete a task, such as word processing, spreadsheet and database management, video editing, games and all of those stuff. Alright, now one thing to note here is that mentioning software names for application software won't give you a single mark. It's even mentioned on the cover page. So you have to write word processing, spreadsheet, database management, video editing, blah blah, and not examples of them like Microsoft Word, Microsoft Excel, this video editor. Alright, now moving on to the analog and the digital data. Now we have two types of data. We have the analog and the digital data. Analog data is basically data that contains value which are in a range, and the keyword here is that it's continuous data, right? We can see in the image below it's continuously varying. They are not fixed values, alright? And then we have the digital data that is discrete, or the keyword binary, right? The data can either be a 1 or a 0, a 1 or 0, right? Now you might be wondering why. Okay, so we have to convert analog data to to digital and digital to analog. Now, you might be wondering why we have to do this. Now, analog data is converted to digital so that it can be processed by a computer, right? And then later on, we will learn that we have the sensors which read analog data and then convert it to digital data. Now, if you are connected to a sensor, your computer is connected to a sensor, the data definitely needs to be converted so that the computer can process it and decide on what to do next. And now digital data is converted to analog so that it can be used to control devices, alright? Now to control a sensor, you will send a signal which is digital, but it gets converted into an analog, you send a digital signal which is converted into analog, alright? And then to convert, we use a digital to analog converter, which is to convert from digital data to analog converter, and then analog to digital converter as well, alright? There will be quite some good questions on these. You can expect 3 to 4 marks or anywhere in the range, alright? And then moving on to the main components of computer systems. Now we have the CPU, which interprets and executes commands, alright? It's the part of the computer that interprets and executes commands from the computer hardware and software, alright? This is something we all have learned, alright, from grade 5 or 6. And then we have the internal memory. The internal memory includes the random access memory, which is the RAM, and then the ROM, which stands for read-only memory. Now, the RAM stands for random access memory, alright? And what it does is basically it holds the instructions for the programs that are currently being used, right? So right now on my computer, the RAM consists of the instructions for this presentation software, because this is currently running. And then the RAM is volatile, meaning it loses data when power is lost. So right now if I turn off my computer, the RAM's content will be cleared. And then we have the read-only memory, which is the ROM. It stores the startup instructions, right? So when I turn on my computer, the BIOS is loaded up from the ROM. And then it's non-volatile, meaning data is not lost even when power is lost. Alright. So similarities include that both are internal memory. They are both primary storage, alright? This is one key thing. The data on both can be read. Both are directly accessed by the CPU, alright? Then the differences include that RAM is definitely volatile and ROM is non-volatile, and then RAM is used to store instructions of programs currently in use, whereas ROM stores startup instructions, right? You can read the rest and add those to your personal notes, alright? I won't be reading through all of them. Now moving on, we have the input and output devices as well, right? Input device is basically a hardware device that allows a user to enter data manually into a computer. Now we have the manual and the automatic input devices. We will learn those later on, not now, alright? And then for now, we're just supposed to know the differences between input and output devices. Input devices send data and cannot receive data to another device, whereas the output devices can receive data but not send, right? Basically, an output device is a hardware device that takes output data from a computer and puts it into a human readable format. Now input device, our mouses, right? And then we have the keyboards, alright, the touch screens. The output device, we can say our speakers, alright, the displays, projectors. A touch screen is both an input and an output device, alright? Now we have the backing storage. Backing storage is basically used to store the user's files and data permanently, alright? Now here we are going to look at two types, which is the hard disk drive and the solid state drive, alright? We are supposed to know the advantages and disadvantages over here. Now those of us with the hard disk drive in our computers, we know that it offers more storage, like 1 TB, 2 TB, and it's generally cheaper compared to SSD, alright. But then it comes with disadvantages, which includes that the data is very slow to access. We might have noticed that even when we are turning on our computers with HDD, they take very long to turn on. They are quite heavier than SSD and they make more noise, alright. They also consume more power because of their read and write heads. We will learn those later on. Now the SSD stores data electronically, right? The hard disk drive stores magnetically. Now the SSD, we have faster data access time because data is electronically stored and there's no need to spin the read and write heads, alright? It's definitely more lightweight and portable because there are no disks, there's no read or write head, alright? Everything is just stored electronically. There's less power consumption because we don't have more mechanics, but then it comes with disadvantages. Offers less storage. With SSD we can see 64 GB SSD, 128, which is very less compared to the 1 terabyte and 2 terabytes, alright. Then compared to HDD, it's very expensive. Not just expensive, very expensive, alright. A 256 GB HDD would be very cheaper compared to a 256 GB SSD, alright. You can even search that up right now and see for yourself. Now, moving on to the interfaces, alright. I'll be using these notes for those, alright. Now, the interfaces basically define the way in which we communicate with the computer, alright. Now we have the graphical user interface, which basically features windows, buttons, menus, alright. Now for example, we can look at this, the first image I had over here, which is the Mac OS, right? We can see we have buttons, menus, alright, graphics, everything is easy to use, alright. Now the advantages include that it's quicker, it's easier, we don't need to learn any commands. So even if we buy someone who has zero computer knowledge, the person can easily learn it and use it. There are fewer errors than we make few errors, right? Because we don't have to type any commands. And then it's intuitive. We can use touch screens with it to pinch in. Like right now, if I zoom into my screen using the touch screen, right, it's more easier, alright. It's intuitive, you can put it like that, alright. And then we have the scrolling and expanding. We can exchange data between applications very easily, alright. And then I can speed up finding commands. We don't have to go through 3 lines of code in order to open the file explorer, alright. We can just click on one button and it opens. Now it comes with disadvantages, obviously. Takes up more RAM, alright. If you have ever run Linux on your computer, you will know that it significantly improves performance, alright. And then it also takes up space on your hard disk because of all these visuals and stuff, alright. And it can be slower for experienced programmers. Now if you have ever used Linux before, you will know that Windows is very slow, alright, compared to that. And then yeah, it's restrictive because it has predefined functions. Now there's not much we can do with these buttons being here compared to a command line interface, alright. One thing that's always in the mark schemes is that the user is not in direct contact with the OS, alright. This is one point you should never forget. It's always in the mark schemes, alright. Now moving on to command line interface, alright. It basically features instructions that are supposed to be typed correctly in order to perform a task. Now I have an example of it here. This is an example of a command line interface, basically all the codes and stuff, alright. So here the user is not restricted to predetermined options. We can do whatever we want with the computer. And then obviously we will take less memory because we don't have any visuals, there's no backgrounds, no buttons, nothing, no animations. And then more processing power is made available because we cut the amount of power we are using for all those visuals, alright. and then the user has more control over the computer. All right, that's obvious. And disadvantages, now if you use Windows or Mac OS like any other normal person would do, um, when you switch to a command line interface, all of a sudden what you'll notice is that the commands have to be learned and they're very difficult to learn. All right, just to open one single app you have to write lines of codes, and if you make a mistake you have to write it again. All right, it takes a lot of time hence. All right, so we have to remember the exact path, name of applications, the command have to be typed in correctly, basically all that I said. All right, now you can look at all of these, pause the video. All right, now we have the dialogue based. We can take the Amazon Alexa for instance. All right, it just talks, there's no coding, there's no buttons, there's no visuals, no animations, nothing. All right, benefits are that it allows hands-free control. Now if you have uh, Alexa in your room, say, and you want music to play, all right, you can just say, hey Alexa, can you play music for me, blah blah blah, and it plays for you without you even having to touch it. All right, and then it's safer to use in environments like when you are driving. You can just say, hey Alexa, can you play this for me, can you open maps for me, can you locate me to the nearest restaurant. All right, without having to look at your phone or something, which can pose safety risks. All right, but then the drawbacks are obviously there. It's expensive to develop, and then limited access, and you can't do much with it. You can't tell it to add something to your checklists, or I don't know, any other things we do with graphic user interface. All right, and then sometimes your accent is difficult for it to understand. Now if my English isn't good and I speak to Alexa, there's no way it will understand what I'm trying to say. And then you even have to speak loud in noisy environments for it to understand, which can be very annoying in some instances. Or imagine you want to play music and then you have to be shouting for it to understand what you are trying to say. All right, it will be very annoying. Then the last one we have is the gesture based interface. This is the most uncommon one, but then yeah, it exists basically. If you guys have ever seen those Apple watches where you basically flip your hand and I think it moves to the next menus or something, yeah, that's basically an example of gesture based interface. Or when you lift up your phone in the Android phones, if you lift up your phone it turns on automatically. All right, and then the advantages are that it allows hands-free operation. All right, now to turn on my phone I don't need to double tap it or press the power button. I just lift it up from the table and it turns on. And then it allows easy accessibility for users with mobility impairments. All right, what that basically means is disabilities. Now if you can't see something, you can definitely use your gestures to control it. All right, in some way. All right, now this can cause a lot of, it has disadvantages as well. There may be a limited number of gestures that can be used. All right, you can't do uh, and every possible thing with it. All right, and even users with disabilities may not be able to do the gestures accurately. All right, and then users have to learn what each gesture does, which can be quite hectic at times. All right, so those are the main ones we should know. The others we can know them. All right, now moving on to the types of computers, we have definitely seen uh, all of these at some part in our lives. I'm sure most of us are using a laptop or an iPad to watch this video right now. All right, so a desktop computer is made up of separate units. We have the monitor, the keyboard, the CPU unit. All right, so its uses are for word processing, spreadsheet, finance, so anything. Over here we don't have to know the syllabus content, it's just common sense. we know that we use a desktop computer for this and this, all right. Now advantages are that it offers separate elements, all right, so you can upgrade easily. If you want to have a better screen, you want maybe a gaming monitor, you can easily switch. And then laptops are more expensive for performance, whereas a desktop you can make one yourself from scratch, all right, and it will be very cheaper. Those of us who like gamings, all right. Now there's lower risk of theft or loss, because who would steal all those individual components one by one, all right. And then yeah, that's it for the advantages, all right. But disadvantages: imagine having to move this desktop from your house to your school every single day. How will you carry all of this, right? It's basically impossible. So it's not portable compared to the laptop, all right. It clutters your desk space. You need a very big desk. And then the power, there's no battery with it, so if light goes off, your PC, your desktop is gone as well. There's a larger footprint, all right. This one is more related to the climate and stuff, all right. Now we have to buy storage media for transferring data and stuff, all right. Self-explanatory, I guess. Now the laptop, we all know what a laptop is. If ironically any of us don't know, um, we can look at this image. This is a laptop from some time back, all right. Basically offer it has built-in components, not separate like the desktop, all right. And then it's more portable. We have, because it's definitely smaller, and I'm sure most of us use it in our schools, and then we bring it back home, we take it back the next day. It's very easy to carry, especially the MacBooks, very small and compact, all right, easy to fit in our bags. Then we have the battery life, which is definitely a plus point. If your light goes off, you can still work with it, or even if you are not at home, you can still work with it, all right. And then the screens tend to be anti-glare, all right. Now if you use them in sunlight, you'll notice that you can still read most of the data, whereas on desktop screens you can't, all right. Now compared to the phone and the tablets, we have larger screens and keyboards, which make it easier for us to type. If any of you have noticed, you try to type the same sentence on your phone and laptop in the same time range, you will make more errors on your phone than on your laptop. You can try it out right now and see for yourself, alright. And yes, computer offers more storage than phones, alright. We have 1 terabyte, 2 terabytes, 512 GB, even more than that. Now disadvantages: there's no um, there's no way we can replace components to upgrade to our needs, right? Sometimes it becomes difficult to even add a more RAM to our computer if we want. We can't really change much of the components, and it's more expensive than a desktop. If you have noticed, MacBooks are way expensive than the iMac, alright, even Windows. And then it's easier for it to get stolen, because it's just one single piece. Someone can just grab it and take it, alright. They tend to be heavier than smartphones, alright. And then the laptops that come with touchscreen have little precision. So if you want to draw something, right now if I want to draw here with the touchscreen, if I want to write okay, let's say I want to draw a laptop, right. You see how the lines are not straight. It takes a lot of practice for it to get straight. But then if I use a mouse right now, alright, let me use a mouse, you can see it's way better than the touchscreen, alright, because it's more precise, alright. Yeah. Oh god. Alright, now moving on to the smartphones. I'm sure most of us have seen those as well. If somehow you haven't managed to see one yet, here's an example, alright. I'm sure you have all been using as well. Basically lightweight, portable, front and back camera, built with batteries. It has a very small footprint, and it comes with a screen keyboard and touch screens. All right. And one second. All right. And then we can use it to text. We can use it to call and stuff. All right. All right. The uses are for text messaging, sending and receiving emails, making phone calls, taking photos, to surf the internet, and internet banking. Now, these are all directly from the mark scheme. So memorize these, understand these. It's even common sense that what do we use our phones for every day? We use it to text our friends, we use it to check our emails, to make calls when we're not home, to our parents and stuff, right? We use it to take photos with our friends. That is common knowledge. It's not even ICT knowledge, alright? Now, advantages include that the smartphone is definitely more portable. You can carry it around in your pocket rather than a desktop computer which needs a whole table, or even a laptop which needs a bag. Now, it's it makes it easier for us to access the internet from more locations. All right, the internet speeds are, they tend to be better. Like we have the 5G band on our phones nowadays, which is faster than the Wi-Fi we get on our laptops. All right. Now the phones come with a camera. All right, makes it easier to take pictures and stuff. Basically anything you can think of over here. Don't restrict yourself to the mark scheme. Anything you can think of as an advantage for a phone, write it. All right. Disadvantages: the smaller screens make it difficult for viewing and for typing. Now imagine having to type a letter from this phone here. See how small the screen is. The amount of errors you'll make is very large compared to if you use even a tablet or a desktop computer. Right? Now a tablet, most of us have those iPads and other Samsung tablets, right? Android tablets, my bad. They are easier to they make viewing the screen easier, reading, typing, because they have larger screens, larger on-screen keyboard, alright. And then the disadvantages include that they are not more portable than the smartphones. And then if we are supposed to use cameras, there's no way we can use a tablet because it has bad quality, and it's easier to use a camera with a smartphone. You can't really take selfies with your tablet. It will be very difficult. Here as well, you can think of how you use your tablet and what disadvantages it gives you. You can write those down and you'll still get the marks. All right. Now moving on to a phablet. It's not very common. Basically a tablet but smaller in size, I think. Has features of both the smartphone and a tablet. All right. Larger screens makes it easier to read and write, same as a tablet. All right. The advantages and disadvantages, you can pause and read from the screen. All right. Now the last part, which is the most confusing part of this whole topic, which is the extended realities and stuff. All right. Now virtual reality, it's basically a technology that produces artificial environments using sensors and lights and screens. All right. If you have ever been to one of those VRs we have in malls and places, they basically attach the device on your head and then you feel like you're in a whole different world. These devices, all right, they have become very common nowadays. And then we have augmented reality, which is used to gather information, all right, and then it visualizes real life appearances. So here is example of augmented reality. You can even take Snapchat as an example. All right, it is augmented reality. It applies filters to your face, emojis and stuff. All right. And then we have extended reality, which is a mix of virtual reality and augmented reality. So it combines the real world with the digital world and interacts with each of them, and so basically allows seamless interaction between the real and virtual worlds. All right. So yeah, and then so one example where we can use this is that, say you want to buy some particular piece of furniture for your house, alright? Now you can have a picture of your of your room, and then once you go to buy it, you can use your phone camera to with a specific software to check how that particular piece of furniture would look in your room, alright? That is what we call all of this extended reality, alright? Now this yeah, so this is basically it for chapter 1. Now you can use these, all that I've said here are basically extracted from the mark schemes as I mentioned in the starting. So you can use these for your revision towards the exams. Alright, if you have any questions, let me know in the comments, I'll answer them. You can also join the Discord server for our community. We You can find AdMath resources, AdMath help over there, physics, chemistry, ICT definitely, and computer science as well, alright? So if you do any of those subjects, make sure to join. The link will be in the description and in the comments, alright? You can get help for any of your doubts. We share useful resources over there as well. You can even talk with other people from the same subject groups, alright? Or just hang out with other friends. Now if you found this video useful, make sure to drop a comment, like it, share it, and share it with your classmates so that they advantage from it as well, alright? That is the main goal of all of this, to help as many people as possible writing ICT, because we all dread this theory paper. It's torture to us, alright? So help as many of your classmates as you can. And then yeah, this is it for this video. I'll see you in the next one, alright?